You carry two genes whose entire job is to stop cancer before it starts. Everyone does. They're not cancer genes, they're repair genes. And for the better part of 2 decades in the United States, one company claimed to legally own them. This is the story of BRCA1 and BRCA2. The names are short for breast cancer: BRCA1 on chromosome 17 and BRCA2 on chromosome 13. But the names mislead. In a healthy body, these are tumor suppressors, caretakers that fix broken DNA and keep a cell from turning cancerous. The danger isn't having them, it's inheriting a copy that doesn't work. For most of the 20th century, breast cancer was thought to be bad luck, environment, not heredity. Then in 1990, the geneticist Mary Claire King ended that argument. Tracing huge families, she proved that a single inherited gene on chromosome 17 drove early-onset breast cancer, and she gave it a name, BRCA1. She had found where the gene was, not yet the gene itself. But knowing a gene's neighborhood is not the same as holding the gene. What followed was a 4-year international race to clone it. In 1994, a team led by Mark Skolnick at a young company called Myriad Genetics crossed the line first, pinning down the actual sequence of BRCA1. But one gene didn't explain every family. A year later, in 1995, a British team led by Michael Stratton at the Institute of Cancer Research found the second gene, BRCA2, on chromosome 13, and published its sequence openly for anyone to use. 2 genes, 3 teams, 5 years. The hunt was over. The fight was just beginning. Here is why a broken repair gene is so dangerous. Every day, the strands of your DNA snap, clean double-strand breaks. BRCA1 and BRCA2 run the precise repair crew. BRCA2 loads a protein called RAD51 onto the broken ends, and it copies the matching, undamaged strand to mend the break exactly. It's error-free repair. Lose it, and the cell has to patch those breaks the sloppy way, and mistakes start to accumulate. This is why the risk runs in families. You inherit 2 copies of each gene. A carrier is born with one already faulty, but the second, working copy still does the job. Cancer begins when a single breast or ovary cell happens to lose that second copy too. With no working repair crew left, that one cell's DNA destabilizes, and a tumor can grow. Now the science collides with the law. Myriad didn't just patent its test, it patented the genes themselves. And with BRCA2, the move was sharper still. Michael Stratton's team had already published the sequence in the open, and Myriad raced to file its own patent on it anyway. Those patents made Myriad the only place in America you could be tested for a BRCA mutation. The test ran around $3,000, and because no other lab was allowed to look, there was no way to get a second opinion on the sequence of your own DNA. In 2013, it reached the Supreme Court. The ruling was unanimous. A naturally occurring gene is a product of nature, and you cannot patent it. Within hours, competing labs announced their own BRCA tests, and the price began to fall. Your genes belonged to you again. Today, a BRCA test is routine, and it carries weight. A woman who inherits a faulty BRCA1 gene can face up to a roughly 70% chance of breast cancer in her lifetime. In 2013, the actress Angelina Jolie revealed that she carried such a mutation and had chosen preventive surgery, and testing surged worldwide. Because knowing early is the whole point. It turns a hidden risk into a choice: screening, surgery, time. And there's a final twist. The broken repair gene becomes the tumor's weakness. Block a second repair enzyme, called PARP, and a healthy cell shrugs it off because its BRCA crew still works. But a BRCA mutant cancer cell, already missing one repair route, now has none, and it dies. The first of these drugs was approved in 2014. The very flaw that caused the cancer is now how we attack it. A locus in 1990, 2 genes by 1995, a courtroom in 2013, and today, a test that lets people see a cancer coming before it arrives. From you can't inherit breast cancer to you can read the odds in your own code. The Gene Channel.